Hello fellow Java developers, welcome back to our making an example of a real-world Apache Camel Application series. In this video we will write unit and integration tests for our route that has a JMS endpoint. We will use Artemis test container for that. Let's begin. Here we have our route that we need to test, but before we do that, let's make some quick fixes to make sure that our previously created tests run normally. First of all, we will annotate our route class with a component, because now it is finished and we need to add it to our camel context. Then we will go to our existing tests, and in this exclude routes annotation, we will add our route that we just added to Spring and consequently camel context. We need to do this for every test, because in every test we're testing just one isolated route. So now when we've done that, we will return to our read document route integration test, and here what we need to do is we need to somehow exclude this SSL context parameters configuration and sign document request mapper from initializing, because even though we don't use them in this test in any way because we've excluded the route, these beans are still initialized and they require this environment variable to be present. Otherwise, Spring context will not be initialized. So we have several ways of dealing with it. The most common way is to add Spring profiles. For example, here we could have added something like profile production, and then when we are running our test which has an active profiles of integration test, then this bean is not initialized. The other way that we could have solved this problem is by just adding these properties into our application integration test YAML and assigning some stub values to them, because we don't use them in our test anyway, and in the test in which we're using them, which is this, we're setting the values explicitly in this set test sign document service properties method. And the last way how we can deal with it is we can just mock these beans with Makita, and it will be initialized with mock. It will not require these environment variables, and Spring context will be initialized normally. And as we don't use this SSL context parameters configuration and sign document request mapper, which has the same problem with environment variable, our test will be running fine. So let's add sign document request mapper and call it excluded sign document request mapper. Now these mock beans will not require these environment variables to be initialized, and our test should run normally. Now, when we've reflected our latest changes in existing tests, we can start testing our new route. First of all, let's look at it and decide what will we be testing in our unit and integration tests. First of all, in our unit test, we will test that the route calls the method on our client send request mapper that constructs a client send request. Then we will test that this client send request Java object is transformed into an XML by this marshall.jackson.xml DSL element and sent to this JMS endpoint with exchange pattern in out set. Then we should test that the response from the JMS is parsed into client send response Java object. Then our message should be sent to this skleok endpoint, and that's it for our unit test. Basically, we're going through the route logic and ensure that it does all the steps that we've specified. We've already created such test for signed document route. Basically, the only difference is that it produces and parses JSON instead of XML, and that it has this HTTP endpoint instead of a JMS. But as in unit tests, we're separating the route logic from the endpoint logic, it doesn't make much of a difference. We will just mock this endpoint, same as we did here in our sign document route. So I will edit out creating a unit test for this route, and we will look at the results. And here we have our JUnit test for our send document route. Basically, it's similar to the test that we did in one of our previous videos. Here we're making use of active profile JUnit, which will make Spring to pick up this application JUnit.yaml properties file. Then we exclude read document route and sign document route because we're isolating our send document route to test it alone. And here we're making mocks for each of the endpoints that the route sends message to and receives message from. Here we have our mock JMS send service, and for this SQL log endpoint we have mock SQL, and for checking the message at the end of the route we've added this mock route finished endpoint, and to isolate our route and replace its from statement we have this test start direct endpoint. Then we're injecting our mocks with endpoint inject, and here with the advice with util configurable helper class that we've created, we're replacing our endpoints with our mocks. And in the test itself, we're creating a signed document response which will be sent to the starting endpoint of our route, because that's what the previous signed document route sends to our send document route. So we're creating this signed document response, and then we also create our client send request object that we will expect our route to produce, and then we write it as an XML string, again to compare it with the XML string that our route should produce, and we create a response. Then we make our mock JMS endpoint to reply with the response that we've created, and we send the message to the beginning of our route. And then we just verify that our route behaves as expected. And that's it. That's our JUnit test for the send document route. Now we need to create an integration test for our send document route. As before, we'll use test containers to provide an external system to our route, and this time it will be ArtemisMQ test container. And in the test itself, we need to check that the ArtemisMQ queue receives an XML with our client send request, and that in the case that this system returns a JMS response, our route parses it and saves the status into the database. So let's start from adding a dependency for ArtemisMQ test container. We will go to our POM XML, and here along other test scope dependencies we will add org.testcontainers ActiveMQ dependency, and let's download it. And when we have it, what we also need to do is we need to provide a connection details to our Artemis server. Here in our application.yaml we have our data source, and in the same section we will add our Artemis connection details. First we need to add broker URL, and then we need to add user and password. of course, as you might have guessed, all these properties will be taken from our environment variables. Let's call this Artemis URL. And same with user and password. We will get them from the environment variables, which we expect our CI/CD system to set when deploying a container with our application. And we already have properties for message queues, names that route will send to and read from. And now we have our ArtemisMQ test containers dependency ready, and we can start writing our integration test. We will create a new send document route integration test class, and here in this class we can use all the annotations that we've had in our previous integration test classes, but of course this time we will need to exclude a different route to test our send document route in isolation. Then we can use same PostgreSQL container configuration that we've used in our sign document route integration test, because we'll need the same PostgreSQL container with table and one row inserted into it, because it will emulate our previous route inserting a log entry into our table. And now what we need to do is we need to add a JMS or Artemis container configuration in our test container configuration class. Let's start with public static, then we will use an Artemis container class, and we will call our method getConfigured Artemis container, and we will not add any parameters because we will not be using them, and we will just return new Artemis container, and the image that we'll use will be Apache ActiveMQ Artemis, and the version will be the last accessible at the moment of recording. It's 2.39.0 Alpine, because we already have other Alpine images. So when we have our Artemis container configured, we can add it to our integration test. Let's also add service connection, because the connection factory is configured by Spring, which means we can use this service connection annotation to make Spring auto-configure its spring.artemis.broker URL user password properties from the values provided by this container. And when we have our containers, we will need to add mock beans, same as we did in our read document integration test, for the same reason, which is that we don't need these beans for our route, but they require an environment property, and we don't want to clutter our code with providing a stub value for that property, so we just mocking these beans and moving on. Then, of course, we will need auto-wired producer template and consumer template and camel context. But in this test, instead of JSON mapper, we will need an XML mapper. So let's specify its class here. And now what we need to do is we need to add some mock endpoint that will add to the end of our route to ensure that the resulting message is what we expect. So we will call it mock route finished, and it will have a value of something like mock send document route finished. Now in our dynamic property source annotated method, we need to set up our properties, which we're doing by creating a corresponding method in our test utils. What we'll do is we'll just copy this method, then we will rename it to setTest send document service properties, and endpoint we don't need, because all the properties that will be setting are this client send request queue and client send response queue. So let's copy these values and let's copy the value of the name of the property itself. And now here we can just specify some test constant to have a name of our property. For example, we can use client send request queue and client send response queue. Now let's go to our test constants class, and here we will create our properties. So let's make it a response, and we will also make a comment indicating to which external service these properties are related. And here at the properties themselves, we need to provide some kind of stub test values for our queues. So let it be client send request queue, and here it will be client send response queue. This way we have set up our client send request and client send response queue properties, from which our route will be reading the response and to which it will be sending its request. Now let's return to our test, where we can call this route test utils set test send document service properties, and to be consistent, let's also rename it to set test client send service properties, because that's the name of the external service that will be reading our requests and responding to our application. Now what we need to do is we need to set up some kind of mock for our external service, because we need to somehow emulate it reading our request and then responding with some kind of response. So before we do that, let's just quickly add a mock endpoint to the end of our route, here with this add endpoint on the route completion method. And now what we need to do is we need to set up our mock client send service. For that, let's create method in our route test utils class. Let it be public static void setup client send mock service. And one of the easiest way to do it is to just add another camel route to our camel context, which will be emulating the behavior of our client send service. For that, we need to have our camel context passed to this method, and when we have it, what we can do is we can add new route builder, implement its method, and here of course we need to add an exception to method signature. Now what we need to do in our mock of this client send service: first of all, we will need to read from JMS queue to which our send document route sends its request, and this is our client send request queue. By the way, that's why we've added its value to a test constants class. Then we need to provide some kind of ID. This is optional, but it's just a good practice to add an ID to every camel route so that it's easier to identify its logs. Then we will need to create some kind of a response, which we will do with this lambda expression, in which we will create client send response object, and to the constructor we need to pass some values. So let's return to our test constants and add some fields that our client send response has. So it has status, message, and a timestamp. In our test constants, we will create client send response status constant, then message, and then a timestamp, which has a type of local date time. So we need to actually change type here, and we will just provide a local date time now, which will be called when we initialize our class. And as a response status, we will use something like client send service status OK. And as message, we will use something like document send. These are just test values, so basically we can write anything we want here. Now let's provide these values to our client send response constructor, and here we will provide message, and last field will be a timestamp. Now when we have our client send response object ready, as you might have guessed, we need to transform it to XML because we're emulating system that replies in XML. And then we will need to send the message to the reply queue specified in the JMS header of an incoming message. As you probably know, we need to use 2D DSL element to resolve an endpoint URI at runtime, and to resolve the value of JMS reply header of the incoming message, we will use camel JMS constants class, and here we need to find JMS header reply to. And the last thing that we need to do is we need to add a preserve message QoS property, which needs to be set to true. If we go to JMS component documentation, we will see that what this property does, it makes camel to use JMS priority, JMS delivery mode, and JMS expiration headers taken from the incoming message instead of from the default values of the endpoint. We need this to preserve a correlation ID of our message for our send document route to be able to correlate the response with the request sent. So basically we're just doing it to have a valid correlation headers. Now what we also want to do is in our test we want to somehow ensure that our test message arrives at this destination and is read by this route. What we can do is we can add a to statement here, and in our method we can accept some kind of mock endpoint. Let's call it mock client send service, and by providing this mock endpoint from our test, we can then check that it received the message and that is a valid XML client send request message. So what we need to do for that to work is we need to create mock endpoint in our test class here with this endpoint inject, and we'll be injecting mock endpoint mock client send service, and the name of the endpoint will be something like mock client send service, and that's the endpoint that we will pass to our setup mock client send service method. And now we have a way to ensure that we send the correct message to the external system. And now finally we can start writing our integration test. Let's call it send document route test, and in the test itself, first what we need to do is we need to create some input message for our route. Let's just go to our unit test and copy the creation of expected requests and responses. Then what will we do here is we will add an exception, and here instead of values provided by us we will use our test constants values, because that's what will be sent by our mock service. And the final field will be client send response timestamp. Now that we have our request and response objects ready, we can send an input message to our route, and we will also need to send headers. That's why send body and headers. The endpoint will be send document route start. that's the direct endpoint from which our route reads an initial message. Then the body will be signed document response, because that's what the previous route sends to our send document route. And now we need to specify headers that again previous routes have set on our exchange. These are such headers as document ID, which is our test value. Then we need to specify owner ID, and we also have the value. Then client ID, and finally what we will need is, as you might have guessed, database log ID header, which will be 1, because same as in our previous test, we've just adding one entry to our database in this add row SQL init script. So when we've sent our message to the route, we'll need to wait until it is processed, and same as in our previous test, it's best to do with waiting on the mock that we've set to our route completion, but we actually haven't injected it yet, so let's do that. And here we will specify our mock route finished, and name will be the same. Now what we can do is we can set that we expect message count of 1, and that the body of the message should be expected response. And now what we need to do is wait until assert is satisfied, and we will just add our default test timeout from our test constants class. When our endpoint that we've added to the end of our route receives one message, and this message is the expected response, we know for sure that our route processed the message fully, and we can assert other things. For example, we can assert that our mock of client send service received one message, and that the message is the expected serialized request. Let's actually make it a string so that we knew that it is a valid XML client send request. Then we'll do the same, waiting until assert is satisfied for a timeout. And what we can do then is we can go to our sign document route integration test and copy query for the database, because we'll be using the same, and same with our assertions. But now as a status, we'll be expecting status that we've specified in our test constants class, because that's the same status that was used to produce a response in our mock of the external service. And it seems like we finished our integration test. Let's run it to ensure that we set up everything correctly. And as you can see, it runs normally, which means that our route works as expected. We could have finished here, but we actually have one more small thing to do. We need to add a unit test for our client send request mapper service, same as we have for our file metadata extractor and sign document request mapper. I will edit out creation of this test, as it is just a simple unit test, and just show you the results. And here we have our unit test for the client send request mapper. As you can see, we just create a sign document response object that we set as a body of the message of the exchange, that is then passed to this create client send request method, and then we check that this create client send request method actually sets a correct body to our message. And that's it. We've completed writing tests for our send document route that integrates with the external JMS system. What will we do in the next videos is we will add an error handling logic to all of our routes, and then we will write integration tests for the whole application. And with that, here is the end of our making an example of a real-world Apache Camel application video. In this video we've created a unit and integration test for our route that interacts with external JMS system. Thanks for joining, be sure to like, subscribe and hit that bell icon. And if you have any comments or questions, leave them down below. I will answer to all of those. See you in the next video. Until then, happy coding!